Hi all, welcome back to another session of Boilchem Tutor. Hope you are all staying safe at home during this COVID-19 pandemic. And once again, I am thanking all of you for the valuable comment and suggestion made to this channel. And I am expecting the same throughout in each session. So in this session, I am mainly discussing some of the separation techniques in chemistry. In that, I am mainly including the topic that is solvent extractions. So in this session, I mainly include what is solvent extraction, what is the principle behind the solvent extraction, and what are the different methods of solvent extraction techniques in chemistry. So coming to the first topic, that is what is solvent extraction. Solvent extraction is otherwise termed as liquid-liquid extraction or partitioning. Again, it is a method of separating a substance or separating a components from a mixture based on the relative solubility of that components in two different immiscible solvent. Immiscible solvent means are those solvent when it mixed together it should form a separate layer. That means an commonly used organic immiscible solvent are water and an organic solvent, because when water and any organic solvents are mixing together, it will form a separate layer. So, and commonly used organic solvent can be dichloromethane or chloroform or ether or benzene, etc. So coming to the advantages of solvent-solvent extractions, it has become one of the earliest technique and a routine separation method for separating both organic as well as the inorganic components. And again, when we are mixing these components to be separated in two different immiscible solvent, there is no chance of precipitations or post-precipitation. That is one of the important advantages of the solvent-solvent extractions. Another important advantages of this solvent-solvent extraction is that it is easy to carry out, and again operation time required for the separation is very less. And another important advantages is that we can carry out this separation technique from trace amount of substances to macro level concentrations of the substances. Again, by proper choice of extracting agent, this technique becomes an excellent separation technique for separating organic, inorganic, as well as bioorganic and radioactive materials without any decompositions. Next, we can discuss the principle behind the solvent-solvent extractions. So, the main principle behind the solvent-solvent extraction is the Nernst distribution law. That is, according to this law, solute will distribute itself between the two different immiscible solvent so that at equilibrium, the ratio of the concentrations of the solute in two different phases at a particular temperature will be constant, provided the solute is not involved in any chemical interactions in either of the phases. That means first we are taking the extractant. That is, extractant means the substances to be separated are first dissolved in a suitable solvent, that is say water. Then we are mixing with another, or we are brought in contact with another immiscible solvent, that is an organic solvent. It can be dichloromethane or chloroform or ether, etc. Then these two immiscible solvent are shaken together and for 10 to 15 minutes. And during the time of the shaking, and this extractant can have a chance to move from or transfer from the organic layer, from aqueous layer to organic layer. And at the time of attaining the equilibrium, the ratio of the concentrations of the substances to be separated in two phases become constant. If there is no interactions between if the extractant is not having any interactions between the aqueous phase or organic phase, that means the extractant should not form any precipitation with the aqueous phase or the organic phase. Then only the ratio of the concentrations of the extractant in two phases become constant. Then that constant is termed as the constant, and it is denoted by the letter Kd, and Kd can be represented as the ratio, that is concentration of X. X means the extractant in one phase. One phase can be aqueous or organic. So conveniently we can take one as the organic phase divided by concentrations of X in aqueous phase. So Kd is equal to concentrations of X in organic phase divided by concentrations of X in aqueous phase. Next, we can discuss the different method of solvent extractions. There are three different methods of solvent extraction technique. One, it is the batch extraction. Second one is the continuous extraction, and third one, it is the counter current extractions. So let us come to the first extraction technique, that is batch extractions. Batch extraction is one of the simplest and commonly used extraction technique to separate the solute from one phase to another. Again, this technique is mainly applied when distribution ratio, that is D, is very large. And the batch extractions is usually carried out in separating funnel. So let us discuss how the batch extraction is carried out experimentally. First, the aqueous layer containing the substances to be extracted is taken in the separating funnel. Then it is brought in contact with the organic solvent, which should be immiscible with the aqueous layer. Then we are shaking these two layers for 10 to 15 minutes. Then it is allowed to attain for the equilibrium. So once the equilibrium is reached, the two layers become clear. Then the denser liquid layer can be collected by opening the stopcock present at the bottom of the separating funnel and in one beaker. Then after collecting the denser liquid, the lighter liquid layer can also be collected in another beaker and used for the further purification process. So let us come to the second extraction technique, that is continuous extraction technique. So when the distribution ratio is very small, then we are using multiple extraction technique. But multiple extraction technique gives so many complications and are too difficult to separate the components from a mixture. So Kirchhoff and Studial devised continuous extraction technique to avoid multiple extraction techniques. So continuous extractions is applicable when the distribution ratio is very small, and it is preferred over batch extraction because it is not necessary to reach the equilibrium between the two immiscible solvents as in the case of the batch extractions. So let us discuss how the continuous extractions is carried out when the extracting solvent, that is the organic solvent taken, is heavier than that of the water. So experimentally it consists of a tube and a reservoir, and the tube is filled with the aqueous solution containing the substances to be separated and the extracting solvent, that is the organic solvent. And the reservoir also contains the same extracting solvent as in the tube. And the tube is again fitted with a condenser. So first the reservoir containing the organic solvent is heated slowly so that the organic solvent get converted into vapor, that is it get condensations and it get converted into vapor and reaches to the condenser, and once it reaches to the condenser it get converted into the liquid and flow inside the tube. So as the extracting solvent or the organic solvent is heavier than that of the water, once the extracting solvent reaches inside the tube, it will come down. So while moving down, all the solute from the aqueous layer get transferred from the aqueous to the organic layer, so that the level of the solution inside the tube increases, and then again the organic layer will fall into the reservoir. And this process is continued until all the maximum amount of the solute get transferred from the aqueous to the organic layer. So when the separation is completed, and we can separate the organic layer by opening the stopcock present at the bottom of the tube, and we can collect the organic layer and thereby moving for the further purifications. Next, we can discuss how the continuous extractions is carried out when the extracting solvent, that is organic solvent, is lighter than that of the water. In this case also, it consists of a tube and a reservoir, and the tube is filled with the aqueous solution containing the substances to be extracted and the extracting solvent or the organic solvent, and then the reservoir can also contain the same organic solvent as in the tube, and the tube is fitted with a condenser, and tube is again connected with a funnel, that is bubbler funnel, and once the reservoir is heated slowly, the organic solvent get converted into vapor, that is undergo condensations, and it reaches to the condenser, and once it reaches the condenser it converted into liquid and it comes to the tube, and once it reaches the tube it passes through the bubbler funnel and it comes down. So when the extracting solvent comes down, as it is lighter, it will flow up. So when the organic solvent is coming from bottom to the up, all the solute from the aqueous layer get transferred from transferred to the organic layer. Thereby again the level of the solution increases and this organic layer will fall again to the reservoir. And this process is again continues until all the maximum separations of the solute from the aqueous layer to the organic layer take place. Next, we can discuss the third method of solvent extraction, that is countercurrent extractions. Countercurrent extractions was discovered by Craig and Post. And in this method, it consists of a large number of chambers, glass tube chamber, around 300 to 400 glass tube chambers are there, which are marked as A, B, C, D, etc. in the diagram. So the aqueous solution containing the substances to be separated is mixed with the immiscible solvent. Immiscible solvent is usually the organic solvent, and then this solution is introduced through the chamber A. So once it is introduced through the chamber A, it then passes through the chamber B. So when the solution reaches the B, the solution is then shaken well. That is, the apparatus is shaken well and for 10 to 15 minutes and then allowed to attain for the equilibrium. So once the equilibrium is attained, then the apparatus is tilted. Then the upper layer or the lower denser layer passes through the chamber C and get collected at the D chamber. So once all the upper liquid layer reaches at the D chamber, then the apparatus is made vertical. So the liquid layer collected at the D passes through the chamber E. So once the liquid layer reaches at the E, it is collected in a beaker. So this process is repeated until all the maximum solute from the aqueous layer get transferred to the organic layer. So one of the important advantages of the countercurrent extraction is that it is useful for the quantitative separations of single component or as well as the mixture of components. Moreover, the time required for the separations is very small. Suppose if we want to separate Fe3 plus ion, that is ferric ion, from the ferric alloy or the iron ore, we can use countercurrent extraction method to separate it. In this case, we are using, that is ferric alloy is mixed with the 6 molar HCl solutions and we are brought in contact with the immiscible solvent, that is ether. That is, we are using ether as the extracting solvent. So we have already discussed that batch extraction is applicable when the distribution ratio, that is D, is very large. But the continuous extraction is applicable when the distribution ratio is small, that is less than 1, and there is a considerable difference from those of other component is greater than 10 raised to 4 means we can use continuous extractions. But when the distribution ratio D is too small means we can use countercurrent extraction. So the countercurrent extractions is applied in industrial as well as in the commercial field for the separations of different components from a mixture. Moreover, this method is useful for the drug analysis also. So that is all in this session. Hope you like this session. Stay tuned for the next session. Till then, bye.